Ever wondered what makes up natural uranium? It's a fascinating mix, primarily composed of two different isotopes. The major component is uranium-238, making up a whopping 99.3%. This isotope's nucleus contains 238 nucleons, which are made up of 92 protons and 146 neutrons. The remainder, a mere 0.7%, is uranium-235, which is slightly lighter with its 235 nucleons comprising 92 protons and 143 neutrons. Now, uranium-235 has a unique property. It is fissile, but what does that mean? In the realm of nuclear engineering, a fissile material is one that can undergo nuclear fission when struck by a neutron of low energy. As it turns out, uranium-235 fits this bill perfectly, but here's a twist. Uranium-238, the most abundant isotope of uranium found in nature, is not fissile. Despite its relative abundance, uranium-238 cannot fission with low-energy thermal neutrons. The binding energy released by uranium-238 absorbing a thermal neutron is less than the critical energy, meaning the neutron must carry additional energy for fission to occur. Thus, while it's fissionable, uranium-238 isn't fissile. Interestingly enough, thorium-232, another naturally occurring heavy metal, isn't fissile either. However, it is fertile and transforms into uranium-233, an excellent fissile fuel material upon absorbing a neutron. This makes it akin to uranium-238, which transmutes to plutonium-239. So why does natural uranium contain more uranium-238 than uranium-235? It all boils down to weight. Uranium-235 molecules are lighter than uranium-238 molecules, allowing them to move faster and pass through membrane pores more efficiently. This results in slight enrichment of the uranium-235 that diffuses through the membrane, while the gas that doesn't pass through is depleted in uranium-235. Switch gears and consider India's beaches. They're more than just scenic landscapes, they hold the key to a nuclear-powered future. Kerala, renowned for its beauty and beaches, is home to a massive amount of thorium, a potential fuel for India's nuclear power program. In fact, India boasts the largest thorium deposits in the world, primarily found in Kerala and Odisha, accounting for over 70% of the country's thorium. Thorium is seen by India's Department of Atomic Energy as a practically inexhaustible energy source that won't emit greenhouse gases. The country's first home-built prototype fast breeder reactor, the 500-megawatt Kalpakkam nuclear plant in Tamil Nadu, has shown how thorium can power the nation. However, thorium alone isn't enough. It needs to be converted to uranium-233 in a reactor before it can be used as fuel, a process demonstrated by the Kalpakkam reactor. To wrap up, it's important to understand the difference between fissile and fissionable materials, with uranium as a prime example. Uranium-235 is both fissile and fissionable, while uranium-238 is only fissionable. Thorium-232, while not fissile, can transmute into the fissile uranium-233. And finally, India's thorium-rich beaches represent a potential game changer in the quest for cleaner, more sustainable energy sources.